Welcome all to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The subject that I am covering in my lecture series is microprocessor KCS 403. Today I am going to cover data transfer schemes, instruction and data flow, timing diagram from first unit of the subject. So let's see that what are the data transfer schemes. The data transfer scheme always wants for sending or receiving the information to or from the processor. So what is the role of the processor? Obviously, sending the data to the input-output devices or to the memory, or receiving the data from the memory and the input-output devices. So it is always the matter of sending and receiving some information in the entire microprocessor operations, or we can say entire microprocessor data transfer scheme. So the communication is not done directly with the input-output device. It is carried out systematically by the help of input-output device by virtue of an input-output port. So until and unless we put input-output port, we cannot operate any input-output peripheral device. The data transfer can be either in two forms, namely parallel or serial respectively. That is, there are two types of communication. Either the bits will be transmitted serially, that is one bit at a time, or the bits will be transmitted parallelly. By virtue of the programmed input access, or rather transferring data in parallel, the data transfer can be possible by using the input-output programmed port or direct memory access scheme. So these two, this is the input-output programmed port. It is a simple way of sending the data or receiving the data. And another one is direct memory access scheme. For this, we need a DMA controller. But this scheme is very beneficial when we want to transfer the bulk of data, because the transmission takes place between the peripheral device and between the memory directly without the intervention of the CPU. So this is very effective scheme in case of bulk transfer. For transferring the data in parallel, we have three different ways by means of which the microprocessor communicates with the input and output devices. So first is the basic or simple data transfer. Next is the status check data transfer. And third is the interrupt driven data transfer. We will look into these three one by one. So when we talk about the basic or the simple data transfer scheme, the simplest data transfer scheme is the basic or simple. This one. The method is beneficial to us when we have accurate knowledge of the input-output timing characteristics. So this is beneficial when we are using those input-output devices whose timing characteristics are known to us. We know their timing characteristics. This type of programmed data transfer scheme is used when the processor input-output devices match in their speed. So we are using the processor and the peripheral devices which have mostly the same speed, which are working in synchronous with each other. Some suitable instructions such as in and out are used for to and from the data transfer of input-output devices. So in and out are the instructions when we want to transfer the data. Suppose we want to, we are talking about 8085 and we want to transfer the data to some port. So how we will write? We will write out 85H. This is the address of the port. So what will this instruction do? This instruction will transfer the contents of the accumulator to the port, this port addressed by this 85H. And if we want to input the data contents from some port to the device, then we will write in 85H. So what will this do? This will transfer the contents of the 85 addressed port to the accumulator. So in this way, this type of simple data transfer scheme can be used using such instructions. Now, we come to the status check data transfer scheme. It's a much more complex process than the previous one. We use this method when there is a lack of accurate knowledge about the timing characteristics of input-output devices. So when we don't know what is the timing clock for either of the devices, for the processor and from the input-output devices, then we will use this scheme, because this scheme will in prior check the status of the data transfer, then only it will transmit or receive the data. So this type of program data transfer scheme is used when the speeds are also different. So suppose we, for this we in 8085 use certain instructions like ready. Ready is the pin through which the signal arrives to the microprocessor and from the peripheral device, and it is used to judge whether the peripheral device is ready for the data transfer or not. So in such schemes, there are always handshaking signals, and these signals are used to determine the compatibility between the two devices, between the processor and the peripheral device, to check if the data transfer data from the peripheral device is ready or not, or if the peripheral device is ready to accept the data or not. So such type of handshaking signals are used to match the speeds of both the devices. So this status check data transfer scheme is useful in those cases where the timing characteristics of both the devices, both the peripherals and the processors, are not known to us. Status information is received by the processor regarding the readiness of input-output device. That is, I have already told you. And for this, we can use the handshaking signals. So for this, handshaking signals are used for the data transfer. Now we talk about the interrupt-driven data transfer scheme. The processor enables the input-output devices and then continues to execute its original program instead of wasting the time checking the status of the input-output device. So what will this do? That when the input-output devices are ready to send or receive the data, then processor is informed through a specific control line, that is the interrupt line. So in this scheme, what is done? That the interrupt line are activated. And whenever the interrupt arrives, the processor is informed about that. And if the processor wants to acknowledge the interrupt, then it will, otherwise it can delay or mask the interrupt. So in this interrupt-driven data transfer scheme, this the checking up of the input-output device is not necessary. What will happen? There is an interrupt line, and whenever the interrupt arrives, it will be informed to the processor. So in this way, there is no need to check the devices continuously. Another data transfer scheme is DMA, that is the direct memory access. This is very special scheme, especially in the case when we want to transfer the bulk data. So in this scheme, the data is directly transferred from the memory to the input-output device or vice versa without going through the microprocessor. This scheme is used when there is the requirement to send the bulk data. Transferring the bulk data using a microprocessor consumes more time. Yes. So in this case, there is no use of CPU. There is no need to use the CPU. So the data transfer between the processor and the peripheral devices can take place directly without using CPU. Therefore, the microprocessor performs the data transfer between input-output and memory using this DMA technique. For a DMA transfer, input-output devices must also contain electronic circuitry to generate control signals. But most input-output devices are not equipped with such facilities. So in this, for this, when the input-output devices are not equipped with the special facilities for the DMA operation, then in that case we use the DMA controller. So to solve this problem, there are many manufacturers from different companies which have invented this special chip, that is the DMA controller. And whatever signals come from the input-output devices, DMA controller interpret that signals and send it to the microprocessor, and in turn microprocessor acknowledge those requests and send back the acknowledgement signal to the DMA controller. So what is happening basically, that there is the processor and there is memory and there is the input-output device. So there is memory, there is input-output device, and in between there is DMA controller. So this is the role of DMA controller. So the request from the input output device will go into to the DMA controller. In turn, DMA controller will send the request to the memory, or we can say the processor. The request will be sent to the processor, and in turn the processor will send the acknowledgement signal, which will acknowledge the input output device in turn, and in this way the connection is established and the communication between the input output device and the memory directly takes place. Now when we talk about the instruction and the data flow, the content of the program counter of 2 bytes is transferred to the address register known as the memory address register. This occurs at the starting of a fetch cycle. So whenever there is any instruction which is to be executed, we know that the fetch cycle is the first one to be done. So during this cycle, the program counter of 2 bytes is transferred to the memory address register. These contents are transferred via the address bus, and once this is done, the timing and the control section of the processor reads the contents of the referred memory address location. After this, the data is sent to the MDR, that is memory data register, with the help of data bus. Now the data is placed in the instruction register, which will eventually decode and execute it. So in this way, as soon as the fetch cycle is interpreted, then the program counter content, that is the address of the next instruction, that is sent to the memory address location, that is memory address register, and these contents are transferred via the address bus. Once this is done, the timing and control section reads the contents of the referred memory location, and those contents are sent to the memory data register, and now the data now the data is placed in the instruction register, which will eventually be decoded and executed. So in this way, the instruction and the data flow takes place in any of the microprocessor operation. So first of all, the instruction is fetched from the memory, and what is the process of fetching? That the address of the next instruction is placed in the memory address register, which will be further transferred through the address bus. That instruction will be fetched. The timing and control section will understand that from where the data has to be fetched. Then the data is transferred to the memory data register, and eventually after being transferred to the instruction register is decoded and executed. Now when we talk about the timing diagram is the diagram which provides the information about the various conditions of signals. Which signals? This is the status and control signals. So the timing diagram basically tells about the various status and control signals during the execution of any instruction. So these can be high or low when a machine cycle is executed. So when we talk about the machine cycles during the execution of any instruction, the basic machine cycles which are available are, that is, first is opcode fetch, memory read, memory write, input output read, input output write, halt, or interrupt acknowledgement. So these basic machine cycles are available in any of the instructions, and during these machine cycles, the various control and status signals change their values, like they can go from high to low or from low to high. And so the representation of such status and control signals during the execution of the instructions is known as the timing diagram. Without the knowledge of this timing diagram, it's not possible to match the peripheral devices to the microprocessors. These peripheral devices includes memories, ports, etc. Such devices can only be matched with the microprocessors with the help of timing diagram. So when the lower address has to be placed on the bus, when the data has to be placed, when the higher order address has to be placed, all these operations takes place according to the timing, according to the clock cycles. And during that, the various control and status signals comes into action. When we talk about the instruction cycle, it is a time taken to complete the execution of a particular instruction. So suppose there is the instruction add P. So what will the instruction doing? it will add the contents of the B register with the contents of accumulator, and the result will go into accumulator. So the time taken to complete this whole instruction is known as the instruction cycle. So for the execution of any instructions, basically two steps are followed, that is fetch and execute. So the time taken, that is the number of T states. Time here denotes the number of T states, because every instruction, everything that we are talking about, it is in terms of T states. So the number of total T states required to fetch and execute an instruction is known as the instruction cycle. The 8085 instruction cycle consists of 1 to 6 machine cycles. So the machine cycles can be any opcode fetch or the memory read or memory write. So suppose we are talking about move A comma B. So the machine cycle here is opcode fetch. So in this way, we have to see, when looking at any of the instruction, we have to see that what all machine cycles are included in a particular instruction cycle. So when we talk about the instruction cycle, we have to note that one instruction cycle is equal to execution cycle fetch cycle plus execute cycle. So we have to keep a note of it, that one instruction cycle is always equal to the fetch cycle and execution cycle. So when we talk about the machine cycle, it is the time required to complete one operation of accessing the memory or input output. So as I have already told, the types of machine cycles available in 8085 are opcode fetch, memory read, memory write, input output read, input output write. So these are all the operations. So the time taken to complete a particular operation, that is either there is some fetching from the reading from the memory, or writing to the memory, or there is some reading from the input output port, or the writing to the input output port. All these are small operations. So the time taken to complete one particular operation, it's known as a machine cycle. And obviously the time taken is in terms of T states. So the number of T states to complete one particular operation of accessing the memory or accessing an input output port or the fetch, opcode fetch cycle, these are all machine cycles. So it's also the time required to complete one operation of acknowledging an external request, as I already told. So one machine cycle may consist of 3 to 6 T states. So it depends that which machine cycle we are considering. In some cases, opcode fetch machine cycle vary from 4, or it can be of 6 T states also. Similarly, the memory read or the memory write machine cycles consist of 3 states. 3 T states. Similar is the case with the input output machine cycle, input output read or write machine cycles. So when we talk about the T states, it is one subdivision of the operation performed in one clock period. These subdivisions are internal states of microprocessors synchronized with the system clock. So T state is also used to refer to a time of one clock period. So basically T state is nothing but one pulse, that is, so this is 1 T. So basically what is a clock? Clock is in this type. Yes, a continuous series of pulses. So we are talking about 1 T. So this is 1 T. Then this is another T. So this is another T. So in this way we count the number of pulses, that is the T states, or we can say the clock cycles. So T state is also used to refer to a time of one clock period. So when we talk about the timing diagram, timers and the timing diagram, so this is the rising edge, this is the falling edge, this is the level. Yes. So we have to note that when the signals are being considered, either at the falling edge or at the rising edge or during the levels. So the time period is T is equal to 1 by F, where F is the internal clock frequency. In this, we can say that this is T1, this is T2, T3, T4 and so on. This is the, suppose in T4 states, the fetch cycle is completed. Instruction cycle is as I have already discussed, instruction cycle is fetch cycle plus execute cycle. So 3 states are for execute cycle and 4 states are for fetch cycle in a particular instruction. So in this way, the instruction cycle in total means these 4 states and these 3 states. Total 7 states are taken by the instruction cycle. So when we talk about the timing diagrams, these are very important. Higher order address bus, lower order address bus, ALE signal, read signal, write signal, input output oblique memory bar. These all signals which are present in the 8085 chip, that is the pin in the pin diagram, we can see all these signals, all these lines. So these are very important while talking about the timing diagram. That was all for today in this lecture. So we talked about these 3 topics, that is the data transfer schemes, instruction and data flow, and timing diagram. So that's all for the day. Thank you.